All right, quotients with radicals and then rationalizing the denominator. So when you're dealing with a quotient, the thing that's really important is to first check to see. So when I'm talking about a quotient, what do you think the problem is going to be set up to look like? Well, and what setup is a division problem? Say it louder. Fraction. Okay, so we're going to have these problems set up to look like fractions. So if we take a problem like, we'll start simple, square root of 5 over 9. The first thing that you always want to check when you get a problem that is a, ooh, I forgot to put my fraction bar. The first thing that you always want to check is to see if your denominator is a perfect square. It's the first thing that you always look for. You want to see if the denominator happens to be a perfect square. So in this case, is the denominator a perfect square? Yeah. So you're just going to break the problem apart. Square root of 5 over the square root of 9, and then simplify. Simplify them individually. Can the square root of 5 be simplified? Can we factor that out? No. There is not a perfect square other than 1 that can go into 5, because the only factors for 5 are 1 and 5. So this cannot be simplified. It's going to stay a square root of 5. However, the square root of 9 can be simplified. What is the square root of 9? 3. So then you wind up getting the square root of 5 over 3, and that's your final answer. You always check to see, yes, it's easy right now. You're right. It is easy right now. You always check to see if the denominator is a perfect square. Now, the question you should be asking me right now is what? What if it's not a perfect square? So let's go ahead. Let's go ahead and take a look at a problem that is not a perfect square. So like square root of 12 over 27. So again, like I said, step 1, check if denominator is a perfect square. In this case, it's not. So if it is not a perfect square, then step 2, simplify if possible. Because sometimes if you simplify the fraction, it might simplify so that you do get a perfect square. Can we simplify 12 over 27? Yeah. What is 12 and 27 both divisible by? 3. So we can go ahead and divide by 3 for both of them, and that's then going to give me the square root of 4 over 9. Do I now have a perfect square for my denominator? Yes. So then I can go ahead and work them both out. Square root of 4 over square root of 9 is going to give me what? 2 over 3. Okay. Let me see here. Try and just give you, try this one on your own. Try those two on your own. All right, for problem number 3, who can raise their hand and tell me what they got? Brent? Close. However, can you simplify square root of 80? Omar? Not just 4 over 5. So you need to simplify the square root of 80, right? And square root of 80 is not 4. Quinn? Very good. 4 square root of 5 over 5. So first thing you check, is the denominator a perfect square? Is the denominator a perfect square? Yeah. The denominator is perfect. The numerator, however, is not. So if we split this up, we have square root of 80 over the square root of 25. Again, 25 is perfect, but 80 is not. So that means I need to break 80 up. Square root of 80 can be broken up into the factors 16 and 5. So that means I have square root of 16 and square root of 5 over the square root of 25. Now, square root of 16 is a perfect square, so I'm going to go ahead and rewrite over that in my little orange so I know it's perfect. What is the square root of 16 again? 4. What is the square root of 25? 5. The only thing that is not a perfect square now is that square root of 5 that's remaining on the top, and that is your final answer. 4 square root of 5 over 5. Salman? Again, you can plug this one into a calculator. What are you going to do when it's variables? Yeah. Number 4, square root of 40 over 98. Square root of 40 over 98. Emiliana, you want to try? Okay. Again, you can simplify square root of 20. Square root of 20 does have a perfect square factor. Salomon? Not 4 over 7. Jimmy Ho? 2 square roots of 5 over 7. Good. Is 98 a perfect square? Come on, guys. Is 98 a perfect square? No. What are they both divisible by? 2. I can divide both of these by 2, and that's going to give me the square root of 20 over a square root of 49, which is a perfect square. Square root of 49 is perfect. Square root of 20 is not perfect, but I can break square root of 20 up. Square root of 20 can be broken up by the square root of 4, the square root of 4 and the square root of 5. Square root of 4 and square root of 5 over the square root of 49. Square root of 4 is going to give me a 2. Square root of 5 is going to stay exactly as it is. Square root of 49 is going to give me a 7. And there's my final answer. Any questions? All right, I'm going to throw some variables in. I'm going to flip the page, okay? We haven't even gotten to the real fun part, rationalizing the denominator. Woo! All right. So let's throw some variables in. It's the same idea that you want to check to see, is the denominator a perfect square? If it's not a perfect square, can you simplify? And then I'll get to that third question. Well, what if you simplify and it still is not a perfect square? That's when we get into rationalizing the denominators, okay? So here, we have the square root of x to the 5th over 81x. So look at our denominator. Is 81 a perfect square? Is x a perfect square? No. So we need to see, can we simplify these? Can this be simplified? X to the 5th over x. Yeah, go back to your rules from last semester. When you are dividing by the same base, what do you do to the exponents? Subtract. So it's almost like you've got 5 x's on the top. Remember that? It's like we've got x, 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 and then you've got 1 x on the bottom and an 81. Well, you can go ahead and get rid of one of the x's on the bottom and one of the x's on top, and it now leaves you with square root of x to the 4th, and then the square root of 81. Now, like we said before, 81 is a perfect square. What's the square root of 81? 9. What about square root of 4? Is that a perfect square? Yeah, so what is it? X to the 2nd power, and that's your answer. My blue is dying. Do I have another? Sorry guys, my blue is dying, so I need to change it out. If I hit somebody, I'm sorry. I know it wasn't going to make it. That's why I said I'm sorry if it hits anybody. All right. Let's go on to the next problem. Square root of m to the 3rd over 9m. Is the denominator perfect? Part of it is, part of it's not, right? 9 is perfect, m is not. So again, it's that same idea. I've got 3 m's on the top. Underneath, I've got a 9 and an m on the bottom. I can go ahead and get rid of this information right here, and that's going to leave me with the square root of m to the 2nd over the square root of 9. Is the 9, or I'm sorry, the denominator is now officially perfect. What about my numerator? Is that perfect? Yeah, even exponent, it makes it a perfect square. So what is square root of m squared? M. And then what's the square root of 9? 3. Try this one on your own. Yeah, honey. Well, you only simplify if it needs to be simplified. Remember, you check to see if it's perfect first. If it's not perfect, then you simplify it. No? Well, yeah, actually, yeah, that, yeah. I don't need that. All right, let me go over it. Denominator, is that perfect? The whole thing? No. 36x. X is not perfect. Okay, the whole thing is not perfect. Yeah, part of it's perfect, but the whole thing's not perfect. So if I ask, is the denominator, when I'm talking about denominator, I'm talking about the whole thing. Is the denominator perfect? No. You need to simplify things then to get to a perfect. Now, I can leave the number alone because the number is perfect. So I want to leave that alone. Even though I could technically simplify 4 and 36, sometimes simplifying it might actually undo a perfect value. So like, for example, if this was a 2 over 36, and I simplified 2 over 36 to 1 over 18, well, then I just got rid of my perfect square on the bottom. I don't want to do that. I want to deal with perfect stuff and then simplify later if need be. But here, this information is not perfect. So we need to go ahead and break that apart. So we've got that square root of 4, and we've got that square root of 36. What I need to do is focus on simplifying this. So we know this originally was, x times x over x. If I simplify it, what am I left with on the top? Just x. So I now have square root of x on the top. Okay? Let's simplify what we can. Square root of 4. Can I simplify square root of 4? To what? To 2. Can I simplify square root of x? No. Square root of x. Can I simplify square root of 36? Yes. To what? 6. Am I done? No. Why not? Because 2 over 6, if you remove this and have 2 over 6, is 2 over 6 simplified? No. What does 2 over 6 simplify to? 1/3. So that means you now have 1 square root of x over 3. I don't have to technically write that 1, though. I could just write square root of x over 3. Okay, we got square root of 20b to the 7th over 25b to the 3rd. Is the denominator perfect? Yes or no? No. Okay, so let's go ahead and break this stuff apart. Take our numbers. We're going to have the square root of 20 over the square root of 25. That stuff is perfect. But let's focus on the numbers. B to the 7th over b to the 3rd, those exponents. What can I do? Subtract them. So if I get rid of the 3, what does the 7 become? A 4. So we're now left with square root of b to the 4th. Square root of 20, can I break that apart? Come on, guys. Square root of 20. That's a basic one. We've been doing this square root of 20. You've done like 5 times. What is it? 2 square roots of 5. You can split it up into square root of 4 and a square root of 5. You still have the square root of b to the 4th. And then square root of 25 on the bottom. Okay. Here's your perfect square. Here's a perfect square. Here's a perfect square. So what's the square root of 4? 2. What's the square root of b to the 4th? B to the 2nd power. What's the square root of 25? 5. And then you still have square root of 5 on the top. That's it. It's final answer. You're just going to have to do a lot of problems and practice and practice and practice until you can eventually get it right. Try number 9 on your own. Okay. Anybody want to give it a shot? Brent?
Yeah, I think 65, and then x is 5 over 5, square root of 5, and then, square root of x, 10, is y 10, sorry.
Okay. Nope. There's a lot of simplifying that could be done. Demi? Closer, but not quite. Antonio? Nope. I'll give one more shot. One more. Vincent, you want to try? Above, what's your denominator? Nope. Real close though. But instead of 25 y to the 5th, it should be 5 y to the 5th. So let's go over it. Let me show you how. Okay. First things first, guys, maybe it might make it easier if you split this problem up into two components. Split it up into your number. And split it up into the variables. First things first, is 125 perfect? No. 125 is not a perfect square. So, check to see if you can simplify it. What would both of these be divisible by? 5. They are both divisible by 5. What's 65 divided by 5? 13. What's 125 divided by 5? 25. Is your denominator now perfect? Yes. Can you simplify square root of 13? No. There's nothing that can be factored out. So the final answer for the number portion is square root of 13 over 5, because square root of 25 is perfect. Now let's focus on the variable portion. Is your denominator a perfect square? Yes. Your denominator is a perfect square. Is your numerator perfect? Can we factor it? Yeah. So we can factor it to square root of x to the 4th, square root of x, and then we'll leave the denominator alone, square root of y to the 10th, because it's already a perfect square. What's square root of x to the 4th? X to the 2nd. Square root of x stays square root of x. What's the square root of y to the 10th? Y to the 5th. Now piece it all together. With your numerator, the only thing that's going to be outside is x to the 2nd. With your denominator, the only things that are outside are 5 y to the 5th. Now for what's inside the radicals. By the time you're done, you should not have any square roots on the bottom. You're never allowed to have a square root on the bottom, which is why later on I'm going to have to teach you how to rationalize denominators in case you have a square root on the bottom. So the only square roots we have left are on the top, square root of 13 and x. And there's your final answer. X squared, square root of 13x, over 5y to the 5th. Some of you came real close to it. Like I said, some of you. All right. We'll do one more. Try that one. Do you have a question? You want to answer it? All right, go ahead, Christopher. What do you do? Let me find my thing. Try again. Say it again. It's not 3x over 8. Solomon? Square root of 3x over 8. Square root of 3x over 8. So again, split it up. Let's look at the number component separately. So we have square root of 3 and square root of 64. Let's look at the variable component separately. Square root of x to the third and square root of x to the second. Starting with the numbers, is that perfect square? 64 is a perfect square, yeah. Can we simplify our factor square root of 3? No. So this is going to say square root of 3 over, what's the square root of 64? 8. That's simplified. It's done. Here, square root of x to the third over square root of x to the second. Now, square root of x to the second is perfect. Square root of x to the third is not. There's two ways that you could technically go about this. Because of the fact that it's variables, and you know, since x to the second is smaller than x to the third, you could go ahead and cancel out all of the bottom. And then you would just be left with the value on the top. Or you could go ahead and factor square root of x to the third as square root of x to the second over square root of x to the second times square root of x. And then you'd have another square root of x to the second on the bottom, and then those would then cancel out. There's two ways that you could go about it. Easiest way, these will cancel out. This becomes a 1. So then you're left with square root of x to the first over nothing, or 1. You know, one value. Then you combine it all together. Square root of 3x over 8, and you're done. Yes? Is the numerator always going to be a square root? Not necessarily. Sometimes they might be perfect squares on both the top and the bottom. However, your denominator always has to be rationalized, meaning there's not allowed to be a square root in your denominator when you're done. Sometimes it will, sometimes it won't. It just depends on the problem. All right, turn to page 11. I'm going to give you a lengthy assignment. I want you to have as much practice as you possibly can. Also, that means that if you get something wrong, it won't be as many points off as if we had less problems. You want to make sure when you're copying these down that you really pay attention to what you're copying. If you miscopy, it's going to mess up your whole entire problem. And I don't give you credit for not writing the correct thing. Thank you. All right. Once you've got those copied down, go ahead and pack up, and I'll dismiss you. Yeah. When it's the variables, if you can get rid of the variables completely on the bottom, go ahead and get rid of them. It might make the non-perfect squares at the top, but then you just rationalize those. Yeah. For like number 14, yeah, you have to get rid of that x. Because that's not perfect. But something like this, go ahead and get rid of that. Simplify that to x to the third, simplify that to y to the fifth, simplify that to z to the second, and then just go ahead and factor out what you need to. But at least then you're done with the fraction. You're not getting a copy? I mean, it's going to be online too. I always put it on there, but here. I don't want me. Okay, here. Here you go. Yeah. Oh, so I need to give it to you then. Row 2. You guys first. Your worksheet should be out on your desk. Go ahead and exchange it by 2 people, please. And your row. 2 people in your row. To the right. You pass it down to the right, and then it wraps back around in your row. Oh, fantastic. Thank you.